Hey Level 3s and welcome back to Lesson 12. This is Part C. It'll be a shorter video, you'll be pleased to know. So let's just get straight into it. So here's another example. This is example 4. So this one here is dissolving ammonium nitrate in water. It's an endothermic process. When 1.8 grams of ammonium nitrate was dissolved in 50 grams of water, the temperature decreased by 2.7 degrees. Calculate the enthalpy change when 1 mole dissolves completely in water, and calculate the mass of ammonium nitrate that would be required to absorb 1.25 kilojoules of energy. So this second part's a little bit new, but the first part is just per normal. So we work out Q equals M times change in temperature times the specific heat capacity, and we get 564.3 joules. Hopefully no questions or issues there. We need to turn it into kilojoules per mole, which is what the question asked. So we need to work out the number of moles. So we take the mass and divide it by the molar mass. We've got the mole, and therefore kilojoules per mole is going to be this joules here, okay? And what we can do here is you can either divide this by 1,000 prior or do it afterwards. It's up to you. It doesn't make a difference. So this divided by this gives you 25,080. Divide it by 1,000. That'll put the kilojoules in there. So just so you know, you could have divided this by 1,000 prior. So you could have done 0.5643, divided it by the 2.25 times 10 to the negative 2, and you would have got the same answer. Hopefully that makes sense. This is just a second method. I wouldn't worry about it. I think it makes more sense, the kilojoules per mole. So I'm just going to cross it off, in fact. Okay, so the next step is, this was a new kind of part to the question. It said, calculate the mass of ammonium nitrate that would be required to absorb 1.25 kilojoules of energy. So 1.25. So 1.25 is far smaller than the 25.1 that we've just calculated. So we know that the mass is going to have to be less than what was added. And so how much smaller? So what we need to work out is, if 1 mole released this amount of energy, then how many moles or absorbed this amount of energy, I should say, because it's endothermic, then how much would 1.25, how much would that be in numbers of moles? So if you take that 1.25 and divide it by our 25.1, it's actually 0.0498 moles. And we know it has to be smaller than 1 mole anyway, so this is consistent with that theory, because 1 mole released this amount of energy. So 1.25 is far smaller than 25.1, so we know it had to be less than 1 mole. And then to turn that into a mass, we times it by the molar mass, and the answer is 3.98. Remembering all of our answers in NCA should be given to 3 sig figs. Hopefully that question makes sense. Don't worry, you will have to practice these a lot, and we're spending the whole next lesson on this. Okay, example 5. Okay, this one's a bit different again. This one is actually a type of neutralization reaction, which they've started to do a little bit more of. So 25 mils of 1 mole hydrochloric acid is added to 25 mils of 1 mole ammonia. Now, because these are both 1 mole, you don't have to worry about which one's going to get used up first and whatnot. They've got the same concentration, so it's 1 to 1. Okay, so we're just going to say that's 1 mole. And if you look here, it says, ammonia solution, and the temperature rose 6.5 degrees. As the neutralization reaction occurred. Calculate the enthalpy of reaction. The mass of the mixture is 50 grams. So they've been nice enough to tell you that the mass that you should be using is 50 grams. They've added this to this, and the mass that you should be using is 50 grams. And there's the specific heat capacity. Okay, so all we have to do is the same as normal. Okay, except we can't calculate number of moles by doing mass divided by molar mass, because we don't have a mass, so therefore our number of moles is just going to be 1 mole. And when we're in class together, we're actually going to do a few more problems of these from the SciPad together to make this make more sense. Okay, so Q equals MCT, 50 they told you, 4.18, change of temperature, there's the joules. We just divide it by 1,000 to get kilojoules, and as we're saying that it was just 1 mole, that's the answer. So the answer is 1.36 kilojoules per mole. Now if we go back, the second part of the question, it says that when the enthalpy of reaction was found experimentally in a school lab, the value obtained was lower than the theoretical value. Account for the difference in values and suggest why, and suggest how this could be minimized. So remember, we've already spoken about this. So the first reason as to why any temperature or any value is lower is because some heat is lost to the surroundings. And if some heat is lost to the surroundings, it means it's not being transferred to the water, which means our value is lower. Okay, another reason could be that it wasn't conducted at standard conditions, so therefore we weren't able to get the value that's been compared to standard conditions. Another reason could be that some heat was lost to the apparatus, okay, to the container, and therefore it wasn't being transferred to the water. So any of those are fine. How could it be minimized? It could be minimized by using an insulated container to try and trap as much of the heat energy as possible. And that's what I've put here. Not conducted in standard conditions. Some heat is lost to the surroundings. Apparatus absorbs some, and thus not all the heat was transferred to the water. Remember, we've got to make that connection, and to minimize this, we could use an insulated container. Okay, petals, that's the end of this video. There are 3 tasks. 1, answer. 2, answer. 3, answer. And I expect you to do those for me, please, to check you can do any questions to me. I'll see you soon for the next lesson.